Hello, viewers. Welcome to another episode of Taxonomy Online Mathematics. In this episode, we want to treat scientific notation, or better still, the standard form of writing real numbers. If you are new, consider to subscribe, like, share, and leave a comment after watching. Now, when we are talking of scientific notation, or better still, the standard form, we are only saying that it is a process of writing a number as product of what? Decimal number and a power of 10. That is a, that is a point, decimal point. So a point b times 10 exponent what? N. Where a is just a number between 1 and 9 inclusively. Meaning it can be 1, it can be 2, up to 9. Then the n is just given by the number of places the point is displaced. Displaced meaning moved. It can be moved to the right or moved to the left. From what? The standard to move. The point is displaced from the standard what? Form. So in this case, every number that will be given, that will be written into a scientific notation or the standard form, should have this description, where b can be any number. B can be any group of numbers. It could even be 5 numbers or 10 numbers. But the a should be only one number before the decimal point. And that number should either be 1, 2, or up to what? 9. So we know that standard form or scientific notation is used basically to write large numbers, simple or easier, and also to write what? A very small numbers what? Easier. For example, if I have a number, as in chemistry we have big numbers, so we have something like this, and I want to write this in a very simple way that can be used in my calculation. Measurement in this form can be reduced in the form a point b, meaning the first number here will be 6 point any other number times 10 exponent what? N. The n is only telling us how many times are we moving a decimal point. There's no decimal point here, so we need to introduce into this point. Also, we can have a measurement that could be in this form, which is too big or too small to write. So how are we able to write this? We can write that in a scientific notation, also in this form. Now let's look at the first one. If in case I have 450 and I am asked to write this number in this form, as in I need to introduce a decimal point. We know that if I divide this number by 10, the 0 will go. If I divide this number by 100, it will become what? 4.5. So if I want to write this, I can say that what? 4.50 is what I'm looking for. But how do I get this? I only get this if I divide this by what? 100. I can only get this, meaning I am dividing this by 10. The first 0 go, divided by 10, the point move this way. It means I am introducing a decimal point, which originally was not here. So this is the same as this. But we can see that the question gives us 450. We are trying to write this in this form. So you can see this and this are not the same. It is only this and this that is the same. So in order for me to maintain the question and the answer to be the same, I need to be able to multiply this expression by 100, as in 450 over 100, which is this expression, times 100. Why? Because 100 will cancel 100 and I will be left with 450, which is the question. Which means if I am writing this expression, it means I have not changed the value given to me. So it means 450 over 100 times 100 is the same as what? 450. But we are saying that 450 over 100 is the same as what? 4.5. It means in this case, I can replace this, which is the same as this, as what? 4.50 times what? 100. You see, I've not changed anything. This value here is the same as what? 450. This value here is the same as 450 over 100 times 100. But we also know that what? 100 can be written as what? Powers of 10. 10 exponents a value or an integer. So this is going to be 10 exponent 2. Meaning I can rewrite this 4.5 times 10 exponent what? 2. The 0 here, missing here, does not change anything. The 0 can come, it can also be eliminated. Most of the time, it's always eliminated. So we can see that this value, which is the same as what? 450, is now written in the scientific word notation. We can say that this is in this form: a point b times 10 exponent an integer. This is also 4.5 times what? 10 exponent an integer 2. This value is the same as 450 because I know my 4.5, which is this, is the same as this. When multiplied by 100 will give me back what? My number. So you can see that if I want to write this number, I have to know that how many times will the point be moved to come in front of a number which is between 1 and 9. You can see that I'll be saying that moving this point, I have to introduce a point which is decimal point. So 1, 2, that's 2 times. That's the 2 times we are seeing. So in a short way, in order to avoid all these long calculations, you are only going to say that I want to introduce a point. So if a number is a whole number without a decimal point, the point is already at the back. So if I'm going to introduce a point, I'm going to move 1, 2, 3, 4, 5, 6, 7. It means it's going to be 6.3 times 10 exponent what? 7. We say that what? The n is given by the number of places the point is displaced. The number of places, place 1, 2, 3, 4, 5, 6, 7. It displays what? 7 places. So we have what? 6.3. I said earlier on that the zeros can be ignored after the decimal point. So now, 7. You can also see that there are sometimes the exponent can be negative. So how do I know that it is positive? It is positive from this expression. You can see this is a whole number, 450. We move the point 1, 2. How many times? 2 times. So your power becomes what? Positive. So anytime you are writing a number, that you are moving the point to the left, you are displacing the point to the left, from the right to the left, your power of 10 is going to be a positive number. Your power of 10 is going to be what? A positive number, as you can see in this form. So simply put, if you are given 480,100 and you are asked to write this also in the standard form or in a scientific notation, you will bear in mind that the point is not here, it's at the back. So you are going to introduce. So how many times? 1, 2, 3, 4. Meaning 4.81 times 10 exponent what? 4. 4 as positive 4 because I am moving 1, 2, 3, 4 to the left. I believe that aspect is correct. Good. Now, if in case we have a very small number, this with a power of positive is for a very large numbers. So if we are having a very small number, we want to write in the scientific notation form. Let's say we have 0.01. Let me add 2 to it. We want to write this number in this form, where in this case already there is a decimal point. But the number that comes before the decimal point is not within this range. 0 is outside this range. It means we need to move the point in a certain number of times so that the first number that comes before the point becomes a number in this range. We can see that this, for me to be able to move this point, if I move this point to this place, it means I am multiplying by 10. If I move it to this place, I am also going to multiply by 10. Which means, in order to write that, I'll be having 1.2. This 1.2 will be equals to multiplication of this by what? 100. You see, this multiplied by 100 gives 1.2. But already this is what? 0.012, which is different from this. We only get this if we multiply this by what? 100. But in what way can we maintain this to look the same as this without changing the figure? That is the only way is what? If I divide this back by 100, if this is divided by 100, this will cancel this 100 and I'll be left with 0.012, which is the same as this. So to maintain this, which is the same as this, meaning that this has to be upgraded. We look at the top, the whole of this is giving 1.2, but we are dividing the whole of this by 100. It means this could also be divided by what? 100. And under indices, I can write this as what? 1.2 times 1 out of what? 100. Because this is 1 times 1.2, 1.2 divided by 100. It means the same thing. And also in the laws of indices, if I have 1 over a number, I can take that as what? An exponent of negative. But this is going to be a power of what? 2, since we have it here. This becomes 1.2 times 10 exponent what? Negative 2. This is going to be 1 over, there's a negative sign, then 2 zeros become what? Power of 2. So this value is the same as this value. Since this divided by this is what we are having here. So you can see that I'm having a negative because I am moving the point from the left to where? The right. So in this case, I'll have 1, 2, 3, 4, 5, 6, meaning 1.73 times 10 exponent negative 6. The moment the point is moving from the left to the right side, your exponent of 10 is going to be what? Negative. I believe you get the concept. If you are moving the point from the right to the left, exponent of positive. Left to the right, exponent of what? Negative. Okay, so let's see if we can employ that. Let's see. If I have we are having this, that is 8,134. We want to write this in what? The standard form. We are aware that the point is always at the back. So we are going to introduce 1, 2, 3, meaning 8.134 times 10 exponent what? Positive 3. Why positive 3? Because we are moving the point to the left. You see, there is no zero, so no need to displace any number or eliminate any number. It is only zeros that we don't write. So in this case, if I have, let's say, 41000, this is going to be 1, 2, 3, 4, 5. So 4.1 times 10 exponent 5. We are not writing these zeros because the zeros after are insignificant in this case. The moment I have this, if I'm going to write this as 100, 10 times itself 5 times, the multiplication of that will introduce the zeros back. So no need writing it. But if I have 0.4811 and I'm asked to write this also in a standard form, it also means that the point is going to move how many times? To the right. 1 times. So we have only this. It means 4.811 times 10 exponent what? Negative 1. So I believe by now you know why we have a negative exponent of 10 and then a positive exponent of 10. I believe we are trying to juxtapose that in your mind. That if I move the point from the right to the left, that is in a very large number. Very large number. The point from the left, the right to the left, give me a positive exponent. A very small number. Very small number. If I'm moving the point is only from the left to the right. I believe you get that. Alright. It is in this case, it's not always going to be that if there is already a point, the points will be after 0. It could also be 81.371. You can be given this, which you are asked to write in a standard form. Don't forget, this is also a small number because of the introduction of the decimal point. So where will the point be moving? Will it moving to the right or to the left? If I move it to the right, I'll be increasing the whole number part, meaning it's going to be 813 if I move it one step. But if I move it backwards, which is moving to the left, how many times? I'll move it this way. So if a number is moving from right to left, do we have a positive number as an exponent or negative? This is going to be 8.1371 times 10 exponent 1, positive 1, because even though we have already decimal point here, that does not make this number to have a negative power, because the point is moving from right to left, right to left, right to left. A positive exponent, positive exponent, positive exponent. It becomes from left to right, then you have a negative. So take note of these 2 points also. It is not always that when there is an already decimal point, it means the point will be moved to the right, meaning negative exponent. I believe this little tutorial will clarify your scientific notation representation of what? Real numbers. In the next episode, we will learn how to add numbers under standard form and also how to apply that in question. Thank you so much for watching. Like, share, and comment if you find this video educative. Subscribe if you are new to the channel. Bye-bye.